Have you ever wondered why volcanoes erupt? Picture a towering mountain spewing molten rock and ash into the sky, a spectacle of nature's raw power. This, my friends, is the mystery of volcanoes. Volcanoes are more than just mountains. They are complex and dynamic systems, a confluence of geology, chemistry, and physics. These natural wonders have been shaping our planet's landscape for billions of years, creating islands, altering climates, and even influencing evolution. Welcome back to Random Realm. I'm Jessica, and in today's journey, we'll delve into the heart of these fiery giants, exploring the intricate processes that lead to their spectacular eruptions. We'll follow the magma's journey from the Earth's mantle to the surface, understand the pressure cooker effect that triggers an eruption, witness the path of destruction, and marvel at the spectacle of eruption. We'll also explore how volcanoes, despite their destructive power, are crucial architects of Earth's geology. So buckle up for a thrilling ride into the world of volcanoes. Stay tuned to uncover the fascinating process of a volcanic eruption. Our journey begins deep beneath the Earth's surface. Imagine diving into an ocean of molten rock and metal, where temperatures can reach up to 9,000 degrees Fahrenheit. Welcome to the core of our planet, the beating heart of Earth's geology. The Earth is like a massive multi-layered cake, each layer with its unique characteristics. The outermost layer, the crust, is where we stand, live, and breathe. Beneath it lies the mantle, a hot, dense layer of semi-solid rock. This is the realm of magma, the molten rock that fuels the fire of volcanoes. Deeper still, we plunge into the core, split into two parts. The outer core, a sea of molten iron and nickel, and the inner core, a solid ball of the same metals. The heat from the core, combined with the pressure from the overlying layers, creates a constant state of flux, the engine that drives Earth's geology. Now let's talk about plate tectonics, the mighty architects of Earth's surface. Our planet's crust is not one solid piece but a jigsaw puzzle of tectonic plates constantly moving and interacting. When these plates collide or pull apart, they create cracks and fissures, pathways for the magma from the mantle to reach the surface. And how does this magma form, you ask? Well, it's all about pressure and temperature. As we descend deeper into the Earth, both pressure and temperature increase. In certain regions of the mantle, the conditions are just right for the rock to melt and form magma. This magma, less dense than the surrounding rock, begins to rise, seeking an escape route to the surface. But the journey of magma is not a simple one. It must navigate through cracks and fissures, sometimes getting trapped in magma chambers, building pressure over time. It's this pressure that ultimately leads to volcanic eruptions, a spectacular display of Earth's internal dynamics. Now let's follow this magma as it begins its journey to the surface. Volcanoes come in various shapes and sizes, and understanding their differences is key to comprehending their role in Earth's geology. We've got shield volcanoes, stratovolcanoes, cinder cone volcanoes, each with its unique characteristics. Our first stop on this volcanic journey takes us to the realm of shield volcanoes. Imagine a massive, gently sloping structure resembling an ancient warrior's shield. That's the distinctive shape of a shield volcano. These giants are primarily built from low-viscosity basaltic lava, allowing it to flow easily and cover vast areas. The low viscosity of the lava also means that shield volcanoes typically have non-explosive eruptions. Instead, lava oozes out, creating expansive, broad plateaus. Mauna Loa in Hawaii is a classic example of a shield volcano, and happens to be one of the largest volcanoes on Earth. Now let's move on to stratovolcanoes, the towering giants of the volcanic world. Picture a majestic cone-shaped structure rising dramatically into the sky. Stratovolcanoes, also known as composite volcanoes, are formed by alternating layers of lava, ash, and volcanic rocks. Cinder cone volcano eruptions are characterized by explosive bursts that propel volcanic material into the air, creating the distinctive cone shape. While they might be smaller in scale compared to their shield and stratovolcano counterparts, cinder cone eruptions can still be quite spectacular. Paricutin in Mexico is a famous example of a cinder cone volcano that emerged in a cornfield in 1943. Imagine a pressure cooker. Now imagine one that's miles wide and deep. That's essentially what's happening beneath the Earth's crust, in the fiery depths where magma forms. This process begins in the Earth's mantle, that layer of our planet situated just below the crust. Here, heat and pressure work together like a grand geological kitchen, cooking up a blend of molten rock, minerals, and gases that we call magma. As the Earth's tectonic plates shift and collide, they create pockets of intense heat and pressure. These pockets are where our geological pressure cooker starts to simmer. Over time, this heat and pressure melt the surrounding rocks, creating magma. But magma is only part of the story. You see, this mixture also contains dissolved gases, primarily water vapor, carbon dioxide, and sulfur dioxide. These gases are trapped within the magma, and as the magma rises towards the Earth's surface, the pressure decreases. Now think about what happens when you shake a soda can and then open it. That's right, it erupts out, doesn't it? Well, the same principle applies here. As the pressure decreases, the gases in the magma start to expand. This expansion increases the pressure within the magma, and eventually, the pressure becomes too much to contain. And that's when we get an eruption. The magma, now called lava when it reaches the surface, bursts forth, often with incredible force. The gases that were once trapped within the magma are also released into the atmosphere, contributing to various atmospheric phenomena. So, in essence, a volcano acts as a pressure relief valve for the Earth. It's a way for our planet to release the immense pressure that builds up beneath its crust. And while these eruptions can be destructive, they also play a vital role in shaping our planet's geology, creating new landforms, and replenishing the Earth's soils with nutrients. The stage is set, the pressure is mounting, but how does the magma reach the surface? Well, stay tuned to find out in our next scene, the path of destruction. Like a determined warrior, magma carves its path to freedom. This is where our story turns from a tale of pressure and heat to one of sheer power and determination. It's a journey of magma, the molten rock from Earth's upper mantle as it pushes its way upwards through the crust, forging a path that we call a volcanic conduit. Now, imagine a city's subway system, a network of tunnels snaking beneath the surface. The volcanic conduit is akin to this, but on a much grander and more destructive scale. It's a channel, a highway if you will, through which magma travels from its subterranean home to the surface. But how does this conduit come into existence, you may ask? Well, it's all about pressure. As the magma rises, it forces its way through weaknesses in the Earth's crust, pushing aside the solid rock in its path. Over time, this magma's persistent pressure carves out a conduit, a tunnel that allows for easier passage. Now let's turn our attention to the recognizable shape of a volcano. You know the one, a towering mountain with a crater at the top. This shape is born from the material that the magma brings with it. As magma rises through the conduit, it carries along pieces of rock, ash, and other materials. When the magma finally reaches the surface, these materials are expelled and accumulate around the vent. Over time, layer after layer builds up, creating the classic conical shape of a volcano. It's fascinating, isn't it? How a process so destructive can create something so architecturally majestic. But remember, this majestic structure is not a testament to tranquility. It's a monument to the powerful forces churning beneath our feet, a signal of the fiery fury that lies beneath. The magma has made its journey, but what happens when it finally bursts free? Well, that's a story of spectacle and awe, of destruction and creation, but that's a tale for the next chapter in our volcanic saga. The moment we've all been waiting for, the grand eruption. Now let's delve into the heart of the spectacle. Picture this. The ground rumbles, the air crackles with anticipation, and then, with a thunderous roar, the volcano unleashes its power. The eruption process is a symphony of elemental forces. At the core, magma, molten rock from deep within the earth, forces its way up through the crust. As the pressure builds, the volcano cannot contain it any longer, and the magma bursts forth as lava. Now, this lava isn't just a river of molten rock, it's a cocktail of elements, carrying with it gases like water vapor, carbon dioxide, and sulfur dioxide. These gases, once trapped in the magma, are now freed, contributing to the plume of smoke and ash that billows skyward during an eruption. But not all eruptions are created equal. Some volcanoes explode with a cataclysmic force, like the infamous Mount St. Helens in 1980. These explosive eruptions can spew ash and debris miles into the air, creating a spectacle that's as terrifying as it is mesmerizing. On the other hand, some volcanoes prefer a slow burn. Take the Hawaiian volcanoes, for example. Their eruptions are typically effusive, meaning the lava flows gently down the slopes, creating a mesmerizing fiery river that can reshape the landscape but tends to be less immediately destructive. Whether explosive or effusive, each eruption is a testament to the raw power of nature, a reminder of the living, breathing planet beneath our feet. And each eruption, in its own way, contributes to the ever-changing face of our world, creating new land, altering climates, and even influencing life itself. The eruption is over, but what impact does this have on our planet? Well, that's a question we'll explore in our next scene. The aftermath of a volcanic eruption is as fascinating as the event itself, and it's an integral part of Earth's never-ending geological story. Volcanoes, far from being mere destroyers, are also creators. They are the architects of Earth, molding and shaping the planet since its formation over 4.5 billion years ago. Volcanic eruptions have led to the formation of many of our planet's distinct land features. From the verdant islands of Hawaii to the towering Andes Mountains, these are all feats of volcanic craftsmanship. But it's not just about the creation of land. Volcanoes play a crucial role in the enrichment of soil. The nutrients found in volcanic ash are essential for plant growth. This ash, once settled, often leads to incredibly fertile soil, enabling lush vegetation to thrive. Regions with volcanic activity often host some of the most productive ecosystems in the world. So while volcanoes may seem like agents of destruction, they are in fact key contributors to the circle of life on Earth. Next time you see a volcano, remember, it's not just a fiery spectacle, but a vital part of our planet's life cycle. And there you have it, folks. A brief journey into the fascinating world of volcanoes and their role in Earth's geology. If you enjoyed this video, don't forget to give it a thumbs up, share it with your friends, and hit that subscribe button for more mind-blowing content. Until next time, I'm Jessica signing off from Random Realm. Stay curious.
It's London Lee.